Welcome back. This is Straight Edge Tutorials, and we are once again back at it. And at this instance, we have a question asking for us to find the values of x and y, given that we have 182x plus 247y equaling to the GCD of 182 and 247. So this whole expression is equal to the GCD of 182 and 247. It has been awarded with 8 marks, and that means there is a little bit of concentration for us to invest in. So okay, let's just jump straight into it. So the solution, we're going to start off by using the Euclidean algorithm, and we're going to find the GCD of these two so that we can find the answer of this 182x plus 247y. So we start off by finding the GCD of 182 and 247. So we'll look for a number, and the number is 247, which is the greatest number. And then we're going to find how many times 182 goes into 247. So it only goes into 247 once, so we write down 1, and by 1 year these are known as coefficients. So we are multiplying 182 times 1 to symbolize or to indicate that 187 goes once into 247. Do we have a remainder? Yes, the remainder is 65. So we clearly write down the remainder. Okay, so what are we doing? We are now taking the first number, the initial number, and the remainder. That's the only thing we need for the next step, because we used 182 first to get a remainder of 65 for us to find 247. So now we are remaining with this expression. So what are we using next? We're going to use 182, and then we are going to divide 182 by 65. So here we come down here, and then we write 182 is equals to, how many times does 65 go into 182? It goes into 182 2 times. Okay, so here we multiply 65 by 2, and then that's 65 goes into 182 2 times. Do we have a remainder? Yes, we do have a remainder, and the remainder is 52. So we clearly write it down. Okay, so now we are going to use this expression, 65 and 52. So now over this side we are writing 65 is equals to, how many times does 55 go into 65? It goes into 65 only once, and it leaves a remainder of 13. So now we are going to use 52 and 13. So 52 is equals to, how many times does 13 go into 52? 13 goes into 52 4 times. So 4 multiplied by 13. So that's 13 goes into 52 4 times. Do we have a remainder? No, we don't have a remainder, so that's 0. So the moment we come across a 0, it means that we should stop creating this sequence of dividing numbers using the coefficients and remainders. And now we look at the 0. Which one is the first positive number that comes after the 0? It is 13. So by looking up here from the first 0 that we come across, and the first number that we come across is 13, we can now come and conclude to say that the GCD of 182 and 247 is 13. So over here I'll come down and write the GCD is 13. And thus the first part of the question has been answered. And now we want to solve for the values of x and y. Okay, at some instance a number can come and say 1, first find the GCD and then solve for x and y, but in this instance it just combined the entire question together. So now we want to find the values of x and y, since our expression is 182x plus 247y. So I'll come down here and rewrite this expression here. So over here I'll say 182, sorry for my handwriting, 182x plus 247y is equals to the GCD of 182 and 247. So since I found the GCD of 182 and 247, I'm no longer going to write this here. I'm just going to come down here and say 182x plus 247y is equals to 13. So now what am I trying to do? Now we want to find the values of y and x. So what are we going to do? We are going to equate for 13, 52 and 65. So we'll take 13 here, which is this first equation here. Why are we taking 13? Because this whole expression, we are taking 13 because this expression has been equated to 13. Yeah, so we'll take this 13 here and we'll say this whole expression equals to 13. So we are going to remove this positive sign and put in equal sign here and equate the equation to 13. So how do we do that? We say, yeah, 13 is equals to 65 minus the 52 over here. 52. I would encourage you to put these coefficients at the far right end of right end of the equation. For clarity purposes, I'll explain later. So it's 152 multiplied by 1, and then we can look for any other equation between these two because we want to substitute. So we can take this one for 65 since it has 182 and 247, which are the numbers that are in our initial equation. So we take 65, we equate it also to 65 and say 65 is equals to 247 minus 182 multiplied by 1. Okay, so with these two equations over here, I can now use them to substitute. Okay, so for simplicity, I'll also do this one for 52 again, and then I'll say 52 is equal to 182 from the initial equation that we made over here minus 65 multiplied by 2. Okay, so now we are continuing with our question. So since we now have these three equations over here, this is the first, the second and the third. We are going to take this one, which says 13 is equal to 65 minus 52 by 1. Why did we take this one? Because our GCD is equal to 13 and our overall equation is also equal to 13, and this is the overall equation here. 182 x plus 247 y is equal to 13. So we take this 13 equation here, 13, and then we write it down like this. And now we want to substitute the values of 65 and put them where we have 65. So we take this whole value here and then we put it here, and then we take the value of 52, which is this value right here, this one, and then we put it over here, and then we multiply this whole expression by 1 since it is symbolized like this. So I'll write it clearly for your understanding, for the sake of your understanding, if I may say, or for your comprehension. So it's 13. I always like to write the whole expression so that I can understand my steps. So 65, I'm going to take this entire expression and substitute it for 65 here. So it's going, I'll open a bracket and I'll put 247 minus 182 multiplied by 1, and then I close the bracket, and then I put this negative sign here, and then I take the values of 52, which is this whole expression, and then I open a bracket, and then I say 182 minus 65 multiplied by 2, which is equal to this expression, and then I close the brackets, and since I have a multiplied by 1 multiplying the whole equation over there, I put it at the end like this. Now it's a bit clearer, so I simplify it to remove the brackets, and then I have 1 by 247 is the same as 247 multiplied by 1, negative sign plus positive, it becomes negative multiplied by 182 multiplied by 1. I hope you understood what I just said. I remove the brackets, and then if this negative multiplies this number over here, it becomes negative 182 multiplied by this one over here, it becomes multiplied by 1. If this negative and negative come, they become positive. If this 65 by 2 multiplied by 1, it becomes 65 multiplied by 2, since 2 multiplied by 1 remains as 2. And now we simplify the whole expression, and before I again put the values of 65 over here, I'll just simplify it a bit so that it can be shorter and less complicated. So I'll come again and say 13 equals to 247 multiplied by 1. If negative 1 subtracts negative 1, we all know that it becomes negative 2, right? So if this negative 182 by 1 subtracts negative 182 by 1, these coefficients add one another, so it becomes negative 182 multiplied by 2. I hope you understood from that out. If this number subtracts the same number as itself, the coefficients will change, they will add one another, and it will become 2. It's a principle, so you should remember it. And then we put 65 multiplied by 2, and now we want to get rid of the 65 since our entire overall equation only includes 247 and 182. So what do we do? We take the value of 65 and then we press it over here into this expression over here, and so we come again, we write 13 is equals to okay, I hope you can see what I'm doing here. Okay, yeah, okay, so it's 18, and then I put 247 multiplied by 1 minus 182 multiplied by 2 plus, then I open a bracket. Now I'm putting the values of 65, so I take 247 and minus 182 multiplied by 1, and then I multiply this value of 65 by 2. Since here it's 65 by 2, this is 65, and then I multiply it by 2. So now I want to simplify this whole expression over here. And what do? I once again rewrite the whole expression. You should not be lazy, but you should write the entire expression. So now if I multiply this 247 by 2, it becomes 247 multiplied by 2. Okay, this 2 here, and then if this positive and negative meet, it becomes a negative. So if this 182 multiplied by 1 is multiplied by 2, it becomes 182 multiplied by 2. So if we use the same law, like the law that we used when we added, we take 247 multiplied by 1, yeah, and then we bring this 247 multiplied by 2 to the side, it becomes plus 247 multiplied by 2, and then 182 multiplied by 2 minus 182 multiplied by 2. Okay, so if we add 247 multiplied by 1 plus 247 multiplied by 2, the coefficients add one another. So here we have 247 multiplied by 3 minus, if we have a minus 1, we get minus 2, right? So here we have minus 182 minus 182. So our coefficients add one another, and we still remain with 182, okay, multiplied by 4. Since we have a 2 here and a 2 here, they add one another. And now our overall expression is this 182x plus 247y, which is equals to 13, the GCD. So we want to find the values of y and x. So y is multiplying 247, okay, and then x is also multiplying 182. So from this expression that we have here, 247 is being multiplied by 3, so we know that y is equals to 3. And 4 is multiplying negative 182, and here we know that 182 is multiplying x, so x is equals to negative 4. Okay, so x becomes a negative 4, and now we have accomplished our mission. Please, if you haven't subscribed to our Straight Edu Tutorials channel, please do so as soon as possible. We want to make sure that we get in touch with one another all the time, and support one another's businesses, knowing one another as well, and keeping in touch. So I've included the email, my email, in the description. Make sure that you can use it if you have any questions, suggestions, and any other ideas that you may come across. If you also have some problems that you want to be solved, you can clearly send them through on the email, and I'll post the videos as soon as I'm done with them. Thank you for your time.